All right, this video is going to be going over how to use the tool probe and the tool measuring probe on the newer VF2 that we have here at the Tech. This option is only available on this one machine, so you do have to do, if you happen to be on one of the other machines, you cannot obviously utilize the tool probe. So the first thing we need to do is bring up the programs that the tool probe and the measuring probe use. First thing you're going to do then to do this, and this is all documented on a setup sheet that's located behind the machine as far as probing a part and measuring a tool with the tool probe. So when you get to your machine, when you get to the machine and you're ready to do this, you definitely have that reference available to you. But we're going to go through it here on the video. So the first thing we want to do is hit Edit. And we're going to hit Program Conversational 3 times. Okay? The first time you turn on the machine, you're going to get this screen up here, Template Not Found. And it tells you to load different template, press F2. So after you hit the F2 key, you get this screen that has a list of programs. You can either use your arrow key or the wheel, and you're looking for program number 9996, and it says Haas VQC Wireless Probe English Increment. Once you have that up, you're going to hit right enter. So from here, these are all your probing options. We have a spindle probe 1 through 9, spindle probe 10 through 18, and your tool setting. Probe calibration is something you're not going to be getting into. If you feel like for some reason it needs calibrated, please come and see me. Then you have your help screen that does have some help options in it. So basically the first 2 options, spindle probe 1 through 9, spindle probe 10 through 8, are measuring the XY coordinates, X, Y, and Z coordinates of your part with the measuring probe. Right now we're going to start off with measuring our tools. So we're going to come down to tool settings. So you highlight that and you hit right enter. Okay? Basically you have 1, 2, 3, 4, 5, 6, 7 different options on how to measure a tool. And it has highlighted which one is open. And this here kind of gives you a brief description of what it's going to do. That's going to be an auto length. That's going to be a manual length. Automatic length rotating. Automatic length and diameter. And so forth. Auto length only, sequential tools. You can do a number of tools, random tools. We're going to do, for this tool, it's an end mill, approximately a 5/8 end mill. That's a roughing end mill. So we're going to highlight that over there, and we're going to hit right enter. So now it's going to bring you a series of questions. What tool number is it? Well, you should know what tool it is because you have this in your program. In this case, we're going to use tool 18. So I'm going to punch in 18. You do not put the T in this case, you just put the tool number, right enter. Okay, now it's looking for an approximate length. It says tool length, and over here it gives you a description of what it's looking for. So it's looking for right above the collar of the tool holder, which would be the top of the spindle, the bottom of the spindle, down to how long that tool is. So you just take a 6-inch ruler and you come over here to your tool, put your ruler up there, and this looks like it's approximately 5.3 inches long. And it's just looking for an approximate number. So our tool is approximately 5.3 inches, so we're going to type in 5.3 and right enter. It's asking you for a tool diameter. I know that's a 5/8 end mill. It may be a little bit smaller than that, but it's just looking for an approximate number. 0.625. Right enter. Then from here it gives you a couple different options. Select create a program, add to current program, MDI, or cancel. Cancel would be, I'm doing something I don't want to do. You go into cancel, you arrow down, hit right enter, it'll get you out of it. Most of the time you're going to be doing it in MDI. Once in a while, maybe if you're doing a production part and you want to make sure you measure that tool every time you run a program, you could add it to a current program. For the most part though, we're going to do MDI, and that's how the setup sheet goes through. So we're going to close our doors. You have MDI highlighted, we're going to hit right enter. And then the MDI page comes up. Okay? And then we're just going to hit cycle start. It goes through a number of different sequences. The tool comes down above the part. and it actually turns in reverse, so none of the cutting edges actually catch on the tool probe. Comes down and measures the top of the part first. I'm sorry, comes down and measures the top of the bottom of the end mill. Now it's going to do the diameter. And you don't have to do this, but we're going to go into the offset page and kind of watch the numbers change. See, it already changed to 5.3779, and now it's working on the 625 diameter end mill. So it actually shows that this end mill actually measures at a 615. This is actually a more accurate way to measure an end mill versus using a micrometer, just for the sole purpose because it's actually measuring it as it's rotating it inside that tool holder. So if maybe for some reason that tool holder is out of center a little bit, this is what it actually should be cutting at. But let's say in our program this is a roughing end mill and I want to leave 20,000 stock for a finish cut. Or maybe I want to just make sure it's cutting the size. So here, 0.020, and I'm going to add that to my diameter. In the wear page, you can do it in the diameter, because remember, when in the program, when it looks up this number, it'll add these two numbers together. So in this case, it would say 0.6354. It would be the same way, doing it this way, it would 0.6354. So when a machine in your program, when it calls up this number, it's going to look for that length and that diameter. So that's our end mills measure now, and we want to measure a drill. Okay, so what we're going to do, you don't even have to call up the drill. We're going to go back into our parameters or our screen with all the programs. We're going to hit Edit, Program Conversation 3 times. I'm going to go back to Tool Settings. I'm going to hit right Enter. Now, with a drill, the only thing I'm concerned about is my length. So I'm going to do an auto length only. So we're going to hit right Enter. It's asking you what tool number. It's in tool number 19. Even though tool 18 is in the spindle, that drill is in tool 19. Okay? This is an auto length drill, so you do not have to tell it approximate length. So we're going to close our doors. Once again, we're going to use MDI. Okay, now if you notice, it erased the other program that was in the MDI and replaced it with this. And if you notice in your program, it actually has a tool change in it. Goes and finds the proper tool that it needs. It knows where that tool, that measuring probe is on the table, and it comes down right on top of it. And if you go into your offset page, once again, you don't have to go here. Puts a value in there. Okay? Diameter doesn't mean nothing on a drill, so we don't have to put anything in there. If you want, that's a 1/2 inch drill. I can put a 1/2 inch value in there just for my purposes only. So that's how you measure all your tools. And there are a number of different options. I didn't go through all of them. But they do self-explanatory. If you're using a face mill, which you have to do that. You're going to press right Enter. And what you're going to do with that face mill is you're going to bring that tool over when it's in the spindle. So one of the cutting edges is right over the top of that tool probe. And then you go through the sequence and it'll just come down that little bit, and you can only do that one tool at a time with the face mill. So now if you have all your tool information in there, we're ready to measure our part, where it is on the X and Y, and you can also do the Z. So the first thing you have to do is call up your tool probe. The tool probes, or the measuring probe, should always be in pocket number 20. So we're going to go MDI, we'll just do T20, and that calls that up. Okay? So now, very carefully, measure your part, or maneuver your probe to the edge of your part. Like I said, very carefully, because it will break. And you want to bring it down just so the center of that probe hits that, we should be pretty good. You need to be within 0.4 of an inch, so a little bit less than a ½ inch in there. If you're not close enough, it'll air out and it'll give you a parameter default, and you'll just have to reset it and do it over. So we got our probe where it needs to be to do the x-axis. So we're going to do that same thing, edit, 1, 2, 3. And like I said, as long as you don't turn the machine off, you don't have to go through that F2 and find your parameter programs. This part will always come up. So these are all measuring programs that you can use for your probe. Here, once again, it gives you a little bit of a description, and it tells you what it's doing. That's a boss, meaning a round part, it'd be a male part sticking up. If you want to do a pocket in the X direction, pocket in the Y. A web is the outside if you want to find the center of the part. But if you get into a part, you say, well, my options aren't really there, you can just hit cancel, and it comes back to your blank screen. We're going to look for 1 through 9. So now we're going to look for in here. That's the probe of bore, if you had the center of a hole like we did previously with an indicator. Okay, here's a probe X plus direction. That means the probe is going to travel in the X plus direction. We want the probe to actually travel in the X negative direction. So here's one that says probe X minus surface. It means the probe's going to go in the X minus surface. So that's the one we want. We're going to hit right enter. Okay? It's asking you for a work offset number. Well, in this case, my program, I used 56, so I'm going to use 56. So then after you hit right enter, you get the screen again, the screen with your 4 options, go to MDI, hit right enter. Okay, the MDI page comes up with a program in it. We're going to close our doors. We're going to hit cycle start. Probe will hit the part actually 3 times. After it does that, it actually put our value into G56. Okay? So now, we're going to maneuver around to the top of the part and do it for the Y. And here you got to make sure that you don't hit your hard jaw and break the probe. Okay, so that's right above our hard jaw. We can close the doors right away. Hit edit, program conversation 3 times, spindle. We're looking for our Y, and we want to make sure the Y goes Y negative. So here's a Y minus surface. We're going to hit right enter. We're working with offset number 56. Screen comes up, MDI, and we're going to hit cycle start. And that's your Y surface, and your offset, you have your X and your Y set there. Okay, so after you do your X and Y, the next thing you want to do is your Z surface. Now, just like you did with the top of the table to the top of your part, you have to give the relationship to where the top of that part is to your tool probe. So basically all you do is get your tool above your part, and without breaking it, you want to be within 400 thousandths of the top of your part. So once you're there, so we're going to hit our edit, program conversation 3 times. Okay? I think it's in spindle probe 1 through 9, so we're going to hit that. And we're looking for a probe or Z surface. Okay, that's what we want to do. We're probing our Z surface. We're going to hit right enter. What's our work offset? 56. So we're going to hit right enter. We want to do this in MDI, right enter. And once we have that, the doors are closed. You can hit cycle start. So there, under our G56, it input a negative 15.037. Okay? So if our top of our part was a finished surface and you weren't machining off the top of your part, you'd be fine. You'd be done here with the Z surface. But let's say you have a rough stock there and you want to machine down some of that material, and in your program, you should have, if you're using a face mill, you should be programming at Z0. So what I want to do is I want to change that here. So if I want to bring that down 20 thousandths, just negative 0.02, and now your Z surface is 20 thousandths below your rough stock. Remember, you want to do that in your work offset number so all your other tools follow along. Now, the one little word of caution here, if you measured your tools off the top of the table, you cannot use a probe to measure the top of your part. You have to use a tool or some other measuring device to find out where the relationship to the top of the part to the top of the table. You can use it for your X and Y, but you have to be consistent in how you measure your tools. If you're using the probe, you have to use the probe for the top of your part. So that would cover majority of your X and Y and your Z. I'll go through one of the other instances where if you want to measure the center of the part as far as the X and the Y. So for the X, what I want to do is I want to put the probe approximately in the middle of that part. And you can do this with a scale. It looks like my rough stock is about 5 3/4 of an inch. So I'm going to move it approximately right about there. Like I said, it just has to be close to the center. Okay, so once I have that done, go edit, program conversation 3 times. I believe the options in here, if you pick 1 through 9, you look, oh, that's not the right one. We'll hit cancel, it takes us out. And let's look in spindle probe 10 through 18. Okay, probe an X web, meaning outside of a part. Okay, if you had the inside of a part, it'd be a pocket, but we're doing the outside. We're going to hit right enter. It's asking you to work offset. We're working with 56. Okay, so now it's asking you X width. What is the actual width of your part? And this is your rough stock, not your finished stock. We measured it roughly 5 3/4. Z depth. How far, when that probe moves over to the side, how far do you want that to drop down? Now you do have to be a little careful. You're working with the Y. You want to make sure you watch out for your jaws. So if you have to use a ruler to get a little bit close, you can. In this case, we don't have any of the jaws on the side, so we're just going to say negative 0.5. If you put a positive 0.5, it's going to try to measure the part above it. Okay? So after you hit right enter, you get those 4 options. We're going to use MDI. There, and then we get our program up, and it's just a matter of hitting cycle start. It'll go through and measure one side, goes over and measures the other side. There. And then that input your X center of that part automatically for you, and it did move to the center of the part also. If for some reason you'd punch in a bad value, you really can't hurt nothing. The machine knows where that part should be. And if you put in, like if our width is 5.75, maybe you put 4.75. That machine, when it comes down and it hits the top of the part, it goes at a speed slow enough where it defaults out, and it'll just give you a program error, some type of an error where it hit a part basically where it knew it shouldn't have. So you're not going to break the part or the probe as long as you're inside the MDI program. You can break it if you're hand wheeling it, you go in the wrong direction, you come down too hard. So do be careful when you're hand moving it around. So that's basically a quick run through on the probes. Like I said, there's a number of different options we didn't cover. Feel free to experiment a little bit and look around. I'm definitely around if you have questions. But like I said, if you just kind of watch what you're doing, you really can't hurt it too much unless you're, like I said, doing it by hand, you can't hurt it. But within the programs, you can pretty much can work it through and just answer the questions that it's prompting you through.